Hello and welcome to this course during which you will learn how to use the oneM2M standard to create applications with connected object. Before talking about the oneM2M standard, let a Euro unregistered trademark S take a look at this introduction to the world of connected objects, which is called the Internet of Things. In this chapter, we'll find out what a connected object is, how it can be used, and the architecture it needs to work. First of all, a bit of history. In the mid-90s the Web 1.0 began to deploy with a very centralized vision. Only a few writers were producing content on a limited number of websites accessed by more and more Internet users. By the mid-2000s, we had moved to Web 2.0, which had become democratized and allowed a large number of people to become players on the web. This period saw an explosion in the number of websites and blogs. For example, nowadays, even if the term is still debated, we talk about the Web 3.0, which mixes different webs, each with their own particular characteristics. The social web sets up social networks, the programmable web offers programming APIs, the physical web puts you in contact with real-world objects, a park meter, a thermometer. The real-time web informs you as soon as information arrives on the web, and finally the semantic web, which allows you to enrich the information published on the web to give it more meaning. The Internet of Things is at the crossroads of all these webs. The Internet of Things could be defined simply as a set of networks of physical or virtual objects that often communicate via wireless networks. We must remember several things in this first definition: the fact that several networks will interact, that there will be both physical entities such as a presence sensor or a controllable lamp, but also virtual entities. For example, all the lamps of a building. And finally, the last important point is that it will be necessary to be able to communicate with all of these entities. This being defined, let us see why the field covered by this book is important. Produced by the Gartner Company identifies the degree of maturity and potential of a set of key technologies. You can see that the Internet of Things is still in its ramping up phase, with full maturity expected around 2020. That's why major companies like Google, Apple and Microsoft are interested in it. It also explains the explosion of startups in this area. We are currently in a high-potential market with a lack of technicians, engineers or trained research. In numerical terms, it is estimated that the range of objects will grow from 15 to 49 billion for an income that will increase from $49 billion to $13 trillion. Few areas have such significant potential. The main reason for this is that IoT makes it possible to do a lot of new things in many areas. It's true in transport with connected or autonomous vehicles, in health with the follow-up of patients at home, in industry with connected factories, in security with geolocation and multiple sensors, or even in energy with the optimization of energy from production to consumption. Let a Euro unregistered trademark S take a closer look at an example of the application of connected objects in the energy field. We will see how to deploy smart meters measuring the energy consumption that will enable the implementation of smart metering. To achieve this, we must first relate a set of elements. First of all, at the user end, for example, for those wanting to reduce their electricity bills who, in addition to having a smart meter, will not only have deployed a set of sensors, such as temperature, presence in the building, outlet consumption, solar panel electricity production tracking, but also actuators to control other elements, to trigger the washing machine, the heating, the blinds, etc. The communication between these elements can be done, for example, using a residential gateway that will also be called gateway. This gateway is connected to the internet and communicates with a data center or cloud and sends data to the electricity operator. This operator has also connected objects deployed in its infrastructure to control it. He also sends all his information to a data center that will allow him to create new services. For example, It will adjust the price of electricity to supply and demand and send you this information. You can then trigger your equipment when the price of electricity will be at its lowest. This second example is developed by a startup that mixes social networks and animals. The goal is to manage strays or the removal of pets. Here we find a cat equipped with a connected collar that emits its position to a gateway using a network adapted to connected objects, that is to say consuming little energy. If the animal goes out of its security perimeter, an alert is sent to a community on their smartphone via a cloud. Finally, in these two examples we find the same type of entities and architecture. There are sensors and actuators that send information to one or more gateways using different protocols. We will talk about capillary networks. Gateways are connected to the internet and interact with a cloud. This cloud also hosts business applications. This is where users will connect via their smartphone, for example. This is the type of generic architecture that we will deploy and use in the rest of this course, but before that, let a Euro unregistered trademark S move on to the next chapter to discover the standards that formalize connected object architecture.